Welcome to today's deep dive. When you interact with a digital directory at like a sprawling corporate campus or a mall, you rarely stop to think about the logistics of that image.
Right. You just touch the screen and it responds,
Exactly. And you instinctively assume the computer running it is just stuffed right behind the glass somewhere.
which is almost never the case.
Yeah, often the actual brain is hidden in a secure, climate-controlled server closet literally hundreds of feet away. And that's our mission today. We are decoding a highly technical product page from HDTVSupply for a device called the Smart-AVI DVX-RX200S CAT-6 digital video receive balloon.
This is a very long name.
It really is. But we want to translate this alphabet soup of AV specs to see exactly how video data travels across commercial spaces.
Yeah, it's a fascinating look at the engineering required to maintain that illusion of seamless technology.
Okay, let's unpack this. I mean, the name itself is a mouthful. Is a balloon just a fancy industry word for an adapter, or is there some actual tech magic happening in this little box?
There is actually a very specific mechanism at play here. Balloon, it actually stands for balanced to unbalanced.
Oh, great.
Yeah, so standard DVI video signals are unbalanced,
Good.
which makes them highly susceptible to electrical interference and, signal degradation over long distances.
So what does the box actually do then?
What this device does is take that fragile, unbalanced video signal, and it balances it by splitting it across the twisted copper wires inside a standard Ethernet cable.
Right, because looking at the spec sheet, it mentions it uses STP-shielded twisted pair CAT-5E or CAT-6 cables.
Exactly.
And it uses those to push a 1920 by 1200 resolution signal up to 200 feet, or I think it maxes out at 220 feet, which is about 67 meters.
Yep, and it's fully compatible with both Mac and PC Windows systems too.
Which is wild to me. I mean, I get that running standard Ethernet is cheaper than running a massive, thick DVI cable, but using a standard CAT-6 network cable for DVI video feels like using a standard water pipe to send a highly specialized package. How does the video signal maintain its integrity over 200 feet of networking wire?
That's a great analogy. And the genius of using shielded twisted pair cables for this isn't just the cost factor. It's actually active noise cancellation.
Wait, like headphones?
Basically, yeah. Because the copper wires inside the CAT-6 cable are tightly twisted together, any electrical interference they pick up along that 200-foot run affects both wires equally.
Oh, I see.
So the balloon at the receiving end reads the difference between the two wires and actively cancels out that common mode noise. It guarantees the integrity of that massive data stream.
Wow. And because it piggybacks on cheap, standardized networking cables rather than, specialized video wires, it completely changes the architecture of a building.
Oh, absolutely.
You can suddenly put high-res screens in environments where a dedicated PC could never survive.
Precisely.
Right.
We're talking about things like information terminals, interactive kiosks, call centers.
Right.
In those spaces, you just can't have noisy, heat-generating computers sitting right next to the user. You need a heavy processing power isolated in a server room,
Yeah.
but you still need flawless, zero-latency video right out on the floor.
Which makes the physical design of this unit make a lot of sense. Instead of a bulky machine, this receiver is basically the size of a deck of cards.
Yeah, it's only 5.8 by 4.4 by 3.5 inches.
And it weighs just 0.6 pounds, barely half a pound, meaning you can just mount it invisibly behind any monitor. It costs $200, comes with a 1-year warranty, and free USA shipping from HDTVSupply.
Not a bad deal for what it does.
But, and here's where it gets really interesting reading through these specs, it clearly states this receiver is completely non-functional on its own. You absolutely must pair it with a separate transmitter unit, the DVX-RX200, to function. So if you need a separate transmitter just to make this receiver work, aren't we essentially just looking at one half of a walkie-talkie set?
That's exactly what it is. Yes, it's a strictly closed ecosystem. The transmitter at the server end breaks the DVI signal down, encodes it onto the CAT-6 cable, and the receiver at the display end decodes it back into DVI.
So you literally cannot have one without the other.
No, they work in tandem to create that closed loop of noise rejection and signal translation.
Fascinating. So what does this all mean for you listening at home? Well, the next time you tap on a digital kiosk at a mall, you'll know that a tiny 0.6-pound receiver box is likely hiding right behind the screen, pulling the video strings from a server room 200 feet away.
It's the hidden physical infrastructure that makes our digital expectations possible.
It really is. But that leaves me with one final thought for you to ponder. If highly specialized physical bridging devices are still required to push a 1920 by 1200 DVI signal through an Ethernet cable just to run a simple kiosk,
Right.
what happens to all this hidden physical infrastructure as our environments increasingly shift toward purely wireless, cloud-based visual displays? Will the physical strings pulling our screens eventually vanish entirely?